Then we need to be in the pyramid. You gotta say this first. No, you be in the bottom. Yeah. Just 10 people tall.
So I think we did them all except for number 6. Is that true? Alright, let's do number 6. And then I got a new target for you, but I forgot to make copies of it, so you'll have to wait a minute while I go do that.
Which of point graph?
Which of the point graph?
No, which point on it?
Oh, y equals the square root of x. 7.
Ben, would you like to read to the class?
Which point of the graph? Y equals. What? Oh,
Ben, do you know how to read?
no.
Okay. Which point on the graph they give you a graph, but you don't really need it. Is closest to the point 7, 0. So this is 7, 0. We'll make use of the graph here. Every single point on this graph has the coordinate x square root of x. You agree with that? Like it's really x comma y, but what is y equal to? Square root of x. So isn't every single point on here x square root of x? So what I want is to find the point that's the closest. So probably like somewhere around here is the closest point. Well, what I want to do is use the distance formula with the point, with the 2 points, x comma square root of x, and 7, 0. Use the distance formula, and then minimize that distance. So the distance formula, I'm sure you guys all remember the distance formula, is y2 minus y1 squared plus x2 minus x1 squared, and then all of that square rooted. So the difference in the y values squared, it's really Pythagorean theorem, it's like a shifted around version of it. Subtract the y values and square it, subtract the x values and square it, and then square root all of that. So I'm going to do that with these 2 points. So y2 minus y1 would be like 0 minus the square root of x. And then square that. And then x2 minus x1 would be 7 minus x. And then square that. So if you looked at, like say it was these 2 points, it's really Pythagorean theorem. Like how far are those 2 apart? It's like x2 minus x1, because it's the difference in the x values. How far apart are these 2? Y2 minus y1, because it's the difference in the y values. So then like a squared plus b squared, that's a squared plus b squared, and that equals c squared, so we just have to square root it. Every single point on this line is that. I'm trying to find, so like, okay, let's just put numbers in. That's 4. What's the x value that goes with it? I didn't really just write it. I did 2.
2.
Over here is 9. What's the x value that goes with it? 3. Every single point on here can be labeled as x comma the square root of x. This is x the square root of x. This is x the square root of x. Yeah, like I'm drawing a random point, but it doesn't really matter where I draw it. What I'm trying to do is find the x value so that when I do x to the square root of x and find the distance between the 2 points, it's as small as possible. So I'm trying to set up how far apart are the 2 points, are 7, 0, and any point on that line. How far apart are they? And then I'm going to take the derivative, set equals 0, and do that process to find, like, to minimize it. Does that help? Can I do that? Did you have a question still, or did that help, or what? No, I'm saying any point on that curve can be labeled as x comma square root of x. My job is to find the x that makes the distance from whatever that point is to here as small as possible. So how far apart are these 2 points? Is this the distance formula? And then we're going to set this equal to 0, take the set equal to min, basically, take the truth. Does that help? Okay. Gilmar, I can never see you in this class. There's usually a giant Jack and a giant Ethan in the way. You're here. How's it going? I can see you and your giant nose. I didn't mean your nose was giant, but it's sticking out because there was a mask on. Weird drink of water. Oh. Alright. So does that set up? Okay. So let's just like pause that and say, like, let's say it was y equals x squared minus 3 and the point 1 comma 4. What are the 2 coordinates that we'd be looking to minimize the distance between? Well, one of them is 1 comma 4. The other is x comma y, but instead of y, what am I going to put? X squared minus 3. So I would do the distance formula with these 2 points. So it'd be like x squared minus 3 minus 4 squared, x minus 1 squared, and we'd square root that. Is that like an understanding maneuver? Alright.
How'd you miss it?
So I made Devin smarter and other people dumber at the same time. So, you want me to just say that again? So, if these were the 2 points that if I was trying to say on y equals x squared minus 3, find the point that is closest to 1 comma 4. Then I would look at it like the 2 points were 1 comma 4 and x comma x squared minus 3. So this is like my xy, but the y value is really x squared minus 3. And I would do my distance formula with these 2 points. So y2 minus y1 would become x squared minus 3 minus 4. And I would square that. Plus x2 minus x1 would become x minus 1. And I would square that. Matthew, are you good?
Yes.
Okay. Delaney. Piggy.
So you like solve for like x if you wanted to,
So, like, really, if you wanted to put, like, y, so that you could put, like, y and y squared there. We're just setting it one variable. Yeah. Am I good to keep going? Okay, so, this is what we want to minimize. So that equals min, right? So I'm going to do some I want to take the derivative eventually, but I would like to do some simplifying before I do, because that looks like a giant mess. So if I square 0 minus the square root of x, I'm really just squaring the negative square root of x. And what's the negative square root of x? Squared. X. Plus. So, square this. Remember, it's not just like 7 squared minus x squared divided by square root of the trinomial. So, like 7 squared would be 49. You'd have x times negative 7, but you'd have it twice, right? So, it'd be minus 14x. Still with me? And then negative x times negative x is plus x squared. That still equals min, because I didn't take the derivative yet. And then I'm going to combine like terms, and I'm also going to write just the 1/2 power, because that's, the form we wanted to take the derivative. So I would have x squared minus 13x plus 49. And now I want to take the derivative and actually like set it equal to 0 and find the minimum value. I didn't get you a packet, did you? Why don't you say something? I'm sorry. I'm sure.
Hey, try.
negative 1/2 times 2x minus 13, right? So then I've got to set the bottom and that equals 0, because I don't know what the minimum distance is, but it's a number, and the derivative of that number is 0. Set the bottom and the top equals 0, which means I need a bottom and a top. So like 2x minus 13 over 2 times x squared minus 13x plus 49. And then I want to set the top equals 0. I want to set the bottom equals 0, but I'll just tell you, it's never going to be the bottom in these problems. So don't worry about that. Because I mean, solving that's a giant pain. I don't even think you'll get a number that, but yeah. Don't worry about it. Just do the top. So if I solve the top, what do I get? 13 over 2, which is 6.5, which makes a lot of sense to me. I'm just looking at that graph. You know, this is at 7. Now I'm saying the x value is 6.5, and what's the y value going to be? The square root of 6.5, which I don't know what that is. But by that point, it's probably somewhere around right there, right? Which makes sense to me that the closest point is, you know, if you got x equals 12, you're telling me the closest point is way over here. That doesn't really make sense, but 6.5 does make a lot of sense, you know? It's pretty close to it. So that is the answer that we'd be looking for. Yeah, right. The chain rule. So you bring down the power, you leave the little guy alone, reduce the power by 1, and then you multiply by the derivative of the inside. Alright, question on that one? Alright, I've got to make copies of your next packet, and then I got one to do with you in that packet, and then the rest are like for you to try. So you can try some of these. I'll be back in a few minutes. Thank you for your patience and understanding. It's difficult.
He had a 7-point lead and he ended up losing like right. How did I do it?
Is he here?
So I gave him the safety. Like, fine. Yeah, it's not paying attention.
Nope.
I gotta make this trip.
Look, I said you could have it.
That's quite close, really.
Stop.
Oh, so they'll be here. Those good. You said everyone. Hi.
There you go, Sarah. Yeah, more.
Bonnie, I'm pretty sure.
Oh yeah.
I'll sure make sure. So call it that. Hey, Devin Bonnie.
So let's do this. Try the first one on here. Then we'll do the other one because the first one on here is just like the one we just did. It's a good opportunity for practice. But are you still getting sick water? That was a really long drink.
Yes, Zach.
What's up, Tevin? The distance formula? Do we need the distance formula? Didn't you write it out? Seven? Seven?
Devin, are you not using your words correctly? Why would you write it down with your head?
Mistakes were made. I put it up there. We're gonna do two more problems together, so I lied. It's not gonna go when I said one. I won't be here tomorrow, so you'll have Khan on the stuff we've been doing this week. Wow. Just no regard for. Because I will be somewhere else. I'm gonna do number 3 next. If you want to take a look at it, try to figure it out. That's cool. If you want to wait, that's cool too.
So there was like 9 square. We got 9. We had to simplify it.
You're saying could you leave it as 9 and come a square root of 9? You can, yeah. So the coordinate of the point that we're looking at, any coordinate is x comma y. Y is equal to the square root of x. So that's our point, and that's our other point. Was it like the exact same problem?
Yeah, it actually is.
Oh, really?
Yeah.
That's unfortunate.
But it actually doesn't have exact. It doesn't have the. It says no illustration. That's the problem. It just says.
This one, there's just no illustration, so it's totally different, really. So here's my formula. Before someone asks, I think I switched the x and the y's, but you're adding, right? So subtract the x values. So I'm just subtracting this direction this time. Square root of x minus 0 squared. And subtract the y values. I think I did that backwards too, but it doesn't matter. As long as you have this. Okay. Are we, does it make sense how I'm getting here? Kind of jumbled that, but are we good on getting this step? So then that is x plus x squared minus 4x plus 4, which is x squared minus 3x plus 4 to the 1/2 power. With me? So that's equal to min, and then take your derivative. So 1/2 times x squared minus 3x plus 4 to the negative 1/2, and the chain rule piece of 2x minus 3 equals 0. And if you make that into a fraction, you get this, and if you set the top equal to 0, 2x minus 3 equals 0, gives you x equals 3/2, which makes a lot of sense. If you're trying to get close to the point 2 comma 0, 3/2 comma square root of 3/2. It's probably right around there, which the shortest point would be whatever has a perpendicular line. That looks like it would be about there. 1 okay? How many had that for 1? Okay. Alright, so let's look at 3. This is the little box thing I cut out yesterday that I was all excited about my physical representation, and then I didn't have the problem with it. So I got a rectangular sheet of paper which has now been ripped. My sad box got ripped. But you're going to cut x inches out from every single side, every single corner. So when you cut out 4 corners that are all x by x, and I fold that up, it makes a box. So the question is, how big should I make that cutout to make the box have as big of a volume as possible? Like, should it be a giant X where you fold it up and the height's really big, or like a really thin X where you just fold up a tiny bit? So, what is the volume of a box? Volume is length times width times height. Well, I had and then these little units here are x, x. This is 10. This is 16. So the length of the old piece of paper or cardboard, was 16. But when I make my new box, the length will just be this portion of it here, because I will have lost x from this side and x from this side. So what is my new length? 16 minus 2x, right? So I had 16, but I took an x out from each side. Same idea with the width, right? I had like a 10-inch long, or 10 centimeter wide sheet of cardboard, and this is my new width. It's just this part, and I've lost x and I've lost x. So is my new width 10 minus 2x? And then what's my height? X. Because that x is the part that gets, I don't know how to draw this, but it gets like folded up and becomes like the height of your new box. Right?
Yeah.
That's my setup. I've got one variable. I want that to have the largest possible volume. So I set it equal to max. Now there are restrictions on this. So just think about, like, I don't know if this happens or not. I didn't do the problem yet. But let's say we got x equals 12. Is that a possible answer? It's not. Could I cut 12 out from both sides? What's the biggest my answer could possibly be? Not 10. 5. And can it actually be 5? It can be less than 5. It has to be less than 5 and greater than 0. It can't be 5 or 0. Because then you would have 5. So like if you go to solve this and you get like 2 and 12, you're just going to use the 2. You know what I'm saying? So I think I would probably make this 16 minus 2x times like 10x minus 2x squared. So I'd do this distributive property first. And then FOIL. So I get 160x minus 32x squared plus 20x squared plus 4x to the third. And I still didn't take the derivative, so that's still equal to max. So that's 4x to the third minus 52x squared, if I combine my terms, plus 160x equals max. Now I can take the derivative and set it equal to 0. So 12x squared minus 104x plus 160 equals 0. I don't think you can factor that. I'm just going to solve it for you in my calculator. Yeah. Does it factor? Do some math. Let me know what you think.
So 12. Yeah. Twice.
Oh, it does. Alright, let's try factor. So we can take out a 4. Boom! Why? 3x squared minus 26x plus 40 equals 0. That's got to be 3x and x. And then we got to try to guess and check here. So that if I foiled it, I would get negative 26x. Take a second to try that. Don't say it. Don't say it. So you're just trying different combinations. Like if I put 8 and 5 here, go through it in your head and see if you get negative 26x. I think it's negative 20 and 2. So if I do negative 20 here, what's negative 20 times x? Negative 20x. And then if I put negative 2 here, that's negative 6x. And if I combine those, I get negative 26x. And if I were to multiply those together, I get my positive 40. You see what I'm doing to factor that? That's a tougher one. But then I can solve both of those. So this will give me x equals 20 thirds. Well, that's like 6 2/3. Can I cut 6 2/3 out of 10? I cannot. So that becomes irrelevant. And this is x equals 2. So again, like we talked about yesterday, make sure you read the question. It might say find the largest possible value. It might say find the dimensions of the box. This one says find the size of the squares. So the size of the squares is just going to be 2 by 2. When I ask for the volume, you can find that. If I ask for the dimensions, you would tell me like 2 by 12 by 6, because you would take 2 out of each of those corners, you know. Because it's a 10 centimeter wide sheet of paper, so if you cut 6 centimeters this way and 6 centimeters this way, you've destroyed your paper space-time continuum. Try to sign up 4. No, it says what size should the squares be in order to create a box with the largest possible volume. You could by the volume. Then you get it wrong. So you're answering a question I did not. What's 2 times 4? You said 10. Well, I answered 2 times 5. Sorry, my friend. We haven't done one like 4 yet, so try and set it up, see what you can do, and then I'll help you set it up, and then I'll find you to shut up and let you guys work. I'm just busy drawing my mind. So I'm going to call those XXY. You want to use the same variables as me? It says the bottom is a square. The top is open, so I don't really know how to indicate that in my drawing. Maybe like that. That's not bad. Yeah. Bottom's glass, and you got the 4 walls on the side, but no top. Maybe it's in my ceiling in my house, and then I can see the fish. So they can drink water. So they can get
But what if
nutrition.
it like flooded out?
It doesn't. I've got a system in place to prevent that. If it snows, they get food.
What if it's freezing?
It doesn't. I thought
You
about it.
swim in?
If I wanted to.
That's fine.
Any more questions? How many would like more time to try it before I just start going? Should I just start going? Is that okay? Okay. So, the aquarium must hold 2916 cubic feet of water. So what's the value? How do I find that? First of all, do we understand, like, it's a square bottom, so that's why I call that X and X. And then the top, the height is a different dimension, so I call that one. So the volume of this aquarium isn't it X times Y? So I could just say X squared times Y equals 2916. With me there?
Yep.
But I want to use the least amount of glass. So that's like the surface area, right? So what is the amount of glass that is required to make the bottom of the aquarium? X squared. And then what about one of the sides? X times Y, but how many sides do you have? So it's 4xy, and that's what I want to minimize. Well, I've got 2 variables there, right? I prefer to have just one. So just try to solve for y up there, so I can replace it right there. This is y equals 2916 over x squared. So then I can really say I've got x squared plus 4x times 2916 over x squared equals min, which I can rewrite as x squared plus 11664 x to the negative first. See why I'm getting x to the negative first? So, like, you can think of it that way, or like I bring that up, it's x to the negative second, and then x times x to the negative second is x to the negative first. Or you subtract them, so like 1 minus 2 is negative 1. Or you cancel, you got 1 left on the bottom, but then you bring it up, and so now it's negative 1. Then I just multiply 4 times the 2916. Follow what I'm stepping in? Or what now? So I think the easiest way is just to go this. I don't want this on the bottom, so I'm gonna bring it up. So now I've got that. And then when you multiply, you add the powers to it. So 1 plus negative 2 is, like x to the 4th times x to the 7th is x to the 11th.
So you just brought it up.
I brought it up because I don't want to use quotient rule when I'm taking the derivative.
Oh, you already have. No, I thought you had. Never mind.
Okay, so now I'm gonna take the derivative. So 2x minus 11664 x to the negative second equals 0. But here's the annoying part: is now you gotta put it back down. You gotta have one fraction. So 2x minus 11664 over x squared. And I've got to get a common denominator and combine these. So what's got to go on the bottom over here? Got to be an x squared. So don't I have to put an x squared on top also? So I really end up with 2x to the third minus 11664 over x squared. And my job is to set the top and bottom equal to 0. Well, I don't have to worry about the bottom because if I solve that, I get 0, and a 0 by 0 aquarium is not holding 2916 cubic feet of water. Doesn't matter, so I just have to solve this. So I would add 11664 to both sides. Divide by 2. 32, and then you gotta be able to solve this. I mean, you'll have a calculator to do this, but how do you uncube something? Take the cube root, so what do you type in your calculator? 5832 to what power? 1/3. I want to say 18, but I don't know. 18. So x equals 18. And then again, what are they asking for? They're asking for the dimensions. So my dimensions are 18 by 18, right? Because I got x times x. By, what do I use to find out the y? Yeah, I got this right here, right? If I do 2916 divided by 18 squared. I get 9. What's 324? 18 times 18? Yeah, I think you're right. And then divide it by 2916 divided by 324. So that's that one. That doesn't ask me for the volume. Wait, what? It should give me 2916. your job is to finish this packet. Let me know if I can help. You know, if you have time right now to work on it. And then you'll have tomorrow to finish, and I'm going to give you some cons to do tomorrow too, because again, I won't be here tomorrow. I'll miss you all.
No.
I really thought you'd have time left to work today. I'm sorry.